हेलो स्टूडेंट्स, वेलकम बैक टू माय चैनल जिसका नाम है वीएस मैथ्स एकेडमी। मैथ्स इन अ वेरी सिंपल वे. सो टुडे वी हैव ब्रॉट अ टॉपिक रूट्स ऑफ कॉम्प्लेक्स नंबर and we are going to explain it in a very simple way. So in complex numbers, this roots of complex numbers, the different type of problems that are asked, you can see here on the screen. That is first type of question that I have written: find the value of 1 plus I root 3 raised to 1 by 4. Okay, second question is find the value of 1 raised to 1 by 3. So you will have to find any nth root of a given complex number. So find value of 1 raised to 1 by 3. It is also called as cube root of unity. So question can be nth root of unity. Okay, here it is cube root of unity, or as you can see, any complex number can be given. Here as you see, x raised to 4 minus 1 equal to 0. This equation we have to solve. What do we mean by this? Okay, see, x raised to 4 minus 1 0 means we actually have x raised to 4 is 1, that is x is 1 raised to 1 by 4. So this will corresponds to fourth root of unity, right? Here you just see it is x raised to 6 is I. That means x is I raised to 1 by 6. So you have to find the sixth root of complex number I. So you will get the problems where you have to find any nth root of any complex number. So you will be given any complex number and you have to find its nth root. So let's see what are the steps followed in this. Okay, and we will proceed. So to find nth root of any complex number x. Okay, suppose x plus iy or a plus ib is our complex number. So what are the steps followed? So first step is we have to convert our complex number x plus iy to its polar form. You can convert to polar form or you can also convert to exponential form. Okay, as you know, polar form and exponential form are similar. Okay, what is the polar form? Polar form is written as r cos theta plus ir sin theta. And what is exponential form? It is written as e raised to I theta. And x plus iy, we say it is a Cartesian form, right? So our first step is to convert the given complex number to its polar form or exponential form. So the step 2, which is very important, in step 2 what we need to do is we need to write this complex number. Okay, this theta which we have got, we need to generalize it. So generalize means we have to add 2k pi. Okay, you know that in theta if we add any 2 pi rotation, okay, then we are going to get the same value. That is called a generalized theta. So we have to do that step, r sin theta plus 2k pi. Okay, if you wish you can write in terms of exponential as I e raised to I theta plus 2k pi. Like this also you can write. So this is important step. Okay, this is very important. I will just mark it by star. And then the last step is we have to take the nth root. Take nth root using De Morgan's theorem. So what is De Morgan's theorem? I will just write the statement here. So we know the statement of De Morgan's theorem. It is cos theta plus I sin theta raised to n is cos n theta plus I sin n theta. So same thing we need to do for 1 by n. Okay, so cos theta plus I sin theta raised to 1 by n. We are taking nth root. So this will become 1 by n times theta and 1 by n times sin theta. Okay, so this is what is the last step that we need to do. And after that, last step is note answers for different values of k. So you will get different values or different answers for only n values of k, that is 0, 1, 2, like this up to n minus 1. Okay, so this will be the last step. So let's quickly see how to handle the problems using this. So here we will start with our first problem, that is 1 plus I root 3 raised to 1 by 4. So we will note it down. So we will start here with our first problem, that is 1 plus I root 3 raised to 1 by 4. So 1 plus I root 3 is the x plus iy, that is the complex number given to us. So from here we get to know what is value of x. X is 1 and y is root 3, right? But we have to now convert. First step is conversion to polar form. So how do we do? What is polar form? In polar form, x is considered as r cos theta and y is considered as r sin theta, right? So first we need to find out the value of r. R, how do we find? We know r is root of x square plus y square. So very simple way you can find out value of r. Here it is coming 1 plus 3, that is square root 4, that is 2. So r is coming 2. If r is coming 2, that means I am getting cos theta is 1 up by 2, and I am getting from here that sin theta is root 3 by 2. So now we can search for the value of theta, which gives cos theta half and sin theta root 3 by 2. So all of us know that for theta pi by 3, that is 60. Okay, cos theta is half and sin theta is root 3 by 2. So like this we have got the value of r and theta. So we can successfully convert our complex number. Okay, 1 plus I root 3 is actually its polar form is 2, okay, cos pi by 3 plus I sin pi by 3. So our first step is complete here. Our second step is generalizing theta. So how do we generalize theta? Generalize theta means we have to add, in theta we need to add 2k pi. So we will write like this. So generalizing theta means we have to change theta to theta plus 2k pi. So we have changed here our theta as theta plus 2k pi. So if we call this complex number z, then our z is becoming as this. Now our next step is to take the nth root. Okay, so here we are supposed to take the fourth root. So take fourth root. So how we will take the fourth root? It is z raised to 1 by 4. That is a given complex number. We have to raise it to power 1 by 4. So it will become, so see what I have done here. I have cross multiply and made the denominator same. Okay, you can take LCM. And so here now raised to fourth power, fourth root. We'll first write the complex number. So what is the complex number? It is 1 plus 6k pi by 3 plus I sin 1 plus 6k pi by 3. Okay, this is my complex number and I have to do raised to 1 by 4 here. Okay, so how we will proceed? It is nothing but 2 raised to 1 by 4 and then this cos 5 plus sin 5 raised to 1 by 4. So using De Morgan's theorem, okay, using De Morgan's theorem, what will happen? This 1 by 4 will come inside and what we are going to get is actually cos of 1 plus 6k pi by 3 into 1 by 4. Okay, so it will become pi by 12. I will directly write, it will become pi by 12. Okay, I hope you have followed. Pi by 3 into 1 by 4, sine of 1 plus 6k pi by 3 into 1 by 4. This 1 by 4 will come in angle. Okay, here I will write in one step and then next step I will modify. So see, this is what we get. Okay, 2 raised to 1 by 4, okay, cos of, I will get 1 plus 6k pi by 12 plus I sin 1 plus 6k pi by 12. And now the last step, that is step 4. You have to take different values of k. K will be taken from 0, 1, 2 up to n minus 1. So what was our n? N was 4. So will be taken up to 3. So 0, 1, 2, 3. You have to substitute for k and you will get the 4 roots of the given complex number. So quickly we will note, and that's the answer. So you can end your answer at this stage, okay, by just writing that k is 1, 2, 3, takes value 0, 1, 2, 3, or you can explicitly note the answers like you can see here we have noted, okay. For k0 we will get this value k1, 2, 3. Okay, from k0 we will k4 we will again start repeating. Okay, if we take k4 it will be the same value what we have got in k0. So we just need to note the 4 different values. So that's it. That is what is the simple solution for the first problem that we have taken. Similar way we have to do for all the problems. Like see, just find the cube root of unity. Okay, here what you have to do, so cube root of unity very easily we can handle. So I'll show you quickly how to do find cube root of unity, or that is it means 1 raised to 1 by 3. So here just see 1 raised to 1 by 3. So here our complex number z. Okay, we have to find this. So our complex number, basic complex number which is given is 1. Okay, that is 1 is 0 plus 1. Sorry, it is 1 plus 0i. Okay, so you have 1, this is x plus iy, that is r cos theta plus I r sin theta. Okay, so you can find out very easily r and theta. In this case we know here r is going to be 1 and theta is going to be 0, because cos 0 1 and sin 0 0. So cos 0 plus I sin 0. Okay, this I have got. Here I have taken r as 1, or I have found out actually, and theta is 0. Okay, you can find this. So you know how to find. I have shown in the first problem explicitly how to find it. So once you write this, then we have to follow the step 2. In step 2, this is very important. Step 2 is very important. We have to generalize the theta. That is, our z will become, okay, this theta will be generalized. That is, we have to add 0 plus 2k pi. Okay, so we will add 2k pi here, and we will add 2k pi here also. So see, this is what we get the complex number as. Then we have to do the step 3. What is step 3? Now we have to take the cube root, that is raised to 1 by 3. So now this number which we have written, I will take raised to 1 by 3 here, 2k pi. Okay, raised to 1 by 3. So De Morgan's theorem we will be using at that 1 by 3 will come in the angle as 2k pi by 3 plus I sin 2k pi by 3. Okay, this is how we have taken. And now the last step, step 4, that you have to write the roots. Note the roots for k varying from. Okay, so k will be varying from 0, 1 and up to 2, because n minus 1, I told n minus 1 here is 3 minus 1, that is 2. Okay, so 0, 1, 2. So here you can note that first root x0 or z0, you can write anything. It will be k0, that is cos 0 plus I sin 0, that is 1 itself. Then x1 is for k1, that is cos 2 pi by 3 plus I sin 2 pi by 3. And x2 is cos 4 pi by 3 plus I sin 4 pi by 3. Okay, you can then again convert this to polar or actual values by putting in calci, or you can just leave like this also. You can also write them in the exponential form. This is e raised to c, it is e raised to 0 I, this is e raised to I 2 pi by 3, and this is e raised to I 4 pi by 3. This way writing helps you in if you have been told to find continued product. Okay, if you see here, find the continued product. Okay, it is asked for this particular question, but if it is asked for other questions, so it will help you if you write it in exponential form. So what is continued product? You just need to write down x naught into x1 into x2. Okay, so in this case, if you write, it will be this into very quickly you can note it down, 4 pi by 3. And if you want to do this product, it is nothing but e raised to I 0 plus 2 pi by 3 plus 4 pi by 3, 6 pi by 3. It is e raised to I 2 pi, and hence cos 2 pi plus I sin 2 pi, cos 2 pi 1, sin 2 pi 0. So the answer is 1. Like this you can do the continue. So very quickly we will see solution of this problem also. Here, because it's a fractional power, only one thing we need to note, that is this complex number which we have taken raised. Okay, this we need to split it as, okay, we have 1 plus 2 plus I root 3 by 2. We need to consider this as cube raised to 1 by 4. Okay, so first we need to take the cube and then we need to do the nth root. So for this number, if you see, r is 1, okay, and theta is pi by 3. So this is cos pi by 3 plus I sin pi by 3. Like this can be written. Okay, so what we need to do here, first we will take z cube. Okay, so z cube is by De Morgan's theorem, it is pi by 3 into 3 plus I sin pi by 3 into 3. So we are actually getting cos pi plus I sin pi. Okay, this it is this that simple. And then we have to take the fourth power. Okay, that is 1/4 root. Fourth root or 1/4 power. So before that, what we need to do, the important step is we need to generalize theta. So first you generalize the theta, that means you write this as cos pi plus 2k pi plus I sin pi plus 2k pi. And then you can continue the fourth root, so z raised to 3 by 4. You can write it as cos of 1 plus 2k pi by 4. Okay, 1 by 4 I am taking inside using the De Morgan's theorem very easily. Okay, earlier I showed in detail, so now I am writing directly. And you have to take k varying from, okay, we have taken fourth root, so 0, 1, 2, 3. Okay, that's it. So like this you will get 4 values, z0, z1, z2 and z3. Okay, you will be getting 4 roots. And what is continued product? So as I showed you in the previous problem, continued products means z0 into z1 it is product of z0 into z1, z2 into z. So see here I have completed it quickly. As I said, when you have to find continued product, it is better to consider in the exponential form, and you can just consider all the values k0, k1, k2 and k3. And then all continued product of all these roots, but exponential multiplication corresponds to just addition of the powers. So we are getting answer as e raised to I 4 pi, and that is nothing but cos 4 pi plus I sin 4 pi and it is equal to 1. So see, very simple way we have covered today's topic, that is roots of complex numbers. We have covered different type of and these are what asked in the exam. Definitely there will be one question of 6 marks and you can very easily attempt. Okay, so like this I'm going to make for all small topics. Okay, so if you want to hear them and get prepared quickly, okay, so please subscribe my channel and press the bell icon so that you will get the notification as soon as I upload the video. I will keep coming with the videos on different topics to make it simple for you, even for semester 2. Okay, in semester 1, if you want me to do particular topic, you can comment me in the comment box.